The ocean drilling program drills, cores, and logs the subsea floor to advance scientific understanding of Earth. Science drilling has provided major insights into the changes to our global climate over millions of years, confirmed the theories of plate tectonics and continental drift, discovered a biosphere of microbes living far deeper than scientists ever predicted life could exist, discovered methane in sediments below the ocean, and altered our thinking about the formation of earthquakes, volcanoes, and tsunamis. Expedition 328 is 50 miles off the coast of British Columbia.
What we're out here to do is to drill a borehole and lower a set of instruments down into the seafloor that will eventually be used to measure things like earthquake activity and be able to provide us with real-time data about stresses and pressures associated with tsunamis. It's also going to give us an opportunity to see how an important energy source formed, methane hydrates.
One of the reasons we want to put these corks in is understanding the subsea floor plumbing, the nature of methane gas migrating and then either being trapped as solid methane hydrate or escaping this process and coming out with the seafloor.
That instrument, the cork, is lowered into a drilled seafloor hole and then sealed off so that those sensors can read very sensitive changes in the tilt direction of the sediment package that they're in, or as pressures change within that hole, so that information will be used to help predict earthquakes, see the strain build up in an earthquake environment as the sediments are squeezed by the subduction process.
"17 educators joined this 10-day expedition to study geosciences."
It's the division between water and free methane gas.
"And develop programs about scientific ocean drilling."
We get to see the 200-foot derrick. We're going to also, in addition to cores, we're going to be working with corks. We'll get to see the moon pool. And it's going to be, actually, geology in action.
Educators are challenged to integrate data from the ocean floor to understand the history of Earth.
It's a high-grade metamorphic rock of basically the mantle.
Subsea floor cores from previous expeditions are studied for insight into climate change.
That's interesting though, isn't it though? At 73, it clearly changes. I mean, presumably that is a different composition to that.
This difference here at the end of the Eocene was also a really big change in global climates. That was the point where we started to first grow ice on Antarctica.
Science educators use their expertise and experiences to develop programs and products about the JR1 resolution and about scientific ocean drilling.
This brings earth science to life for my students. They'll be able to see how we know the research that's done, that there is evidence of plate tectonics, and this is how we gathered that evidence, and this is how it's interpreted. This JR1 resolution expedition is just going to be an amazing experience for them. They'll be on board ship with me.
We need to figure out what kinds of sediments we have and describe in as much detail as possible the sediments that we've recovered.
I actually am hoping to be able to understand a little bit more about ocean science, be able to tie that into a geospatial education world.
One of my ideas for how I'll apply this experience is writing a possible series of children's books that would be sort of like choose your own adventure type books, I'm really interested in how geology can tell us a story about the history of the Earth.
The product that I'm going to produce from this is going to be an online, internet-based visualization to take smear slides or samples from the sediment and put them on a microscope and take high-resolution photos so that, again, people within an online setting can zoom in and look at the microfossils that we looked at and really explore this wealth of knowledge that we were able to experience firsthand, because not everybody is going to be able to have this specific experience.
So from here, what I will do, we'll go out at teachers' conferences, in our classrooms, through telecommunications. We'll spread this information as we learn to try to show that science is dynamic, it is ongoing, and it's really fun to do. Thank you.